In this video, I want to look at whether the alternating harmonic series, so negative 1 to the n over n, determine whether it converges absolutely. So remember, a sequence is absolutely convergent if the series, so in this case from 1 to infinity, of the absolute value of the terms in the given series converges. This is what we need to determine. Does this series converge? If we're verifying whether it converges absolutely. So if you take the absolute value, so this negative 1 to the n is either negative 1 when n is odd or positive 1 when n is even. Either way, the absolute value of that numerator is 1. In the denominator, you just got n, which is throughout chapter 9 can be assumed to be a positive integer. And so the absolute value of n, if n is a positive number, then this is just n. So when you take the absolute value, this turns into the series 1 over n, which is the harmonic series we've looked at previously. Sorry, my son's in the background. Which we showed with the integral test that this diverges. Or p series you have now. P series with p equal to 1. When p is less than or equal to 1, a p series diverges. So this series we know diverges. Since the series with the absolute values diverges, then the answer to this question is no. The alternating harmonic series does not converge absolutely. However, if we look at the original series, so the given series, negative 1 to the n over n, this is an alternating series. And whenever you can apply the alternating series test, that's probably what you want to do. It's a pretty straightforward test to apply. So alternating series test in this case, if we check first whether the limit of the non-alternating part here, so we'll just call it 1 over n, is 0, which it is. And then is it decreasing? Are the terms decreasing? So again, ignore the alternating piece of this. So ignore the negative 1 to the n and just look at it as 1 over n. 1 over n plus 1 would be less than 1 over n, greater denominator, smaller fraction. So an plus 1 is less than an, which is the second condition with alternating series test. And so alternating series test says this series converges. Okay, but it's not absolutely convergent. And there's a name for that. It's called conditionally convergent, which is going to come up in the notes later on. But let me make a point about, so absolute convergence. So here, I mean, if you think about this sum, so 1 over n, we're talking about 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4. Okay, going on forever. Turns out, so by the integral test, that this sum diverges. It doesn't, the terms are approaching 0, but not fast enough. And so this sum, the partial sums, never really level off and approach a finite number. They just keep increasing without bound. Compare that with the terms if we expand this this series, which we just showed converges by the alternating series test. So the terms in this sum would be negative 1 to the first over 1. And then negative 1 to the second, which would be positive 1 over 2. And then negative 1 over 3. And then positive 1 over 4. When you plug in n equals 1, n equals 2, n equals 3, and so on. So looking at the sum here, you can see why this is maybe more likely to converge, because it's like you add a little bit, you subtract a little bit. You add a little bit, you subtract a little bit. You're less likely to have that runaway sum sort of situation with an alternating series as you are with a non-alternating series. These are more likely to just increase without bound. Whereas when you're alternating, when you're plus and then minus, plus and then minus, then, like I said, you're less likely to have that runaway sum situation. And so the broader point I wanted to make here is that an alternating series is actually more likely to converge. If you see the negative 1 to the n in your expression here, that does make a series much more likely to converge compared to one that's, say, always positive. So that's why absolute convergence is actually like a higher level of convergence. We're saying that we can make every term positive and it still converges when something's absolutely convergent, when we take the absolute value. Whereas having the terms alternate actually keeps things a little more even keel. It makes it more likely to converge. So just having that in the back of your head when you're working on these problems with absolute convergence, conditional convergence that are going to come up later on, have that in mind, that when it alternates, it's more likely to converge compared to a series that's always positive. That makes it harder for the sequence to converge.